Hello everybody, in this video we are going to continue looking at our calculating dosages questions, but we're looking at them based on body surface area. So again, this is similar to the weight when we're looking at applying it to weight. A lot of times it's done with children and pediatric dosages, but in this case we determine the body surface area to calculate how much medication we should give versus just looking at the body weight. There's two ways you can do this. You can do this using a formula or using the West Nomogram, which is a chart that we can use as a sort of approximation of their body surface area. If you need to be more exact, then you're using the formula. So let's first look at the West Nomogram. This can be used to determine body surface area. There's a part in the center that you can use if the child is of standard weight and height. On the chart it says normal height and weight, but I like to use the word standard instead. So the children of standard height and weight, you only need the weight to determine body surface area, and if they're of standard height and weight, then you can kind of approximate their body surface area with this. So let's practice just using that part of the chart first. So we're going to do it for a child of standard height and weight for 30 pounds and 7 pounds. So let's go over to our West Nomogram here. So this is what it looks like. Okay. There is one in your textbook, and there's one here, and I'll link below the video where you can find this nomogram. Okay, but if you notice, this section here in the center is for children of, it says normal height and weight, and you can just use that part. You can ignore the rest of the chart. You're just going to do this. So for 30 pounds, what we're going to do, I'm just going to zoom in here, and I'm looking at this section right here. This is my 30 pounds. It's in pounds, so if you're given kilograms, you'll have to convert over. And this is my surface area, and 30 is right on 0.60 square meters. So a child of standard height and weight weighing 30 pounds is 0.60 meters squared. And if we look for 7 pounds, let's go down to our 7 pounds is right here. So it's just a tiny bit above this line. Now, to figure out what this line is for, you're going to have to kind of look between the 20 and 25. Now, the little dashes aren't always the same between each measurement. So you need to look at the measurements given above and below and determine what each dash is for. In this case, each dash is going to be 0.01. So this is going to be 0.21, 0.22, 0.23, and 0.24. So we can kind of use an approximation here and say that the body surface area is going to be 0.22 meters squared. So again, it's just sort of an approximate. If you need something more accurate, you're using the outside pieces of the nomogram or the formula. So let's say 0.22 meters squared. Okay, if they're not of standard height and weight, but you still want to use the nomogram, then you're going to be using the outside pieces. Height can either be in centimeters or inches, and weight can either be in pounds or kilograms. So be really careful as you're using this chart that you're using the correct side of the scale. Okay, again, the measurement and the spaces are not consistent throughout the whole nomogram, so really make sure you're looking at the measurements above and below to determine what each of the little dashes are. And you want to make sure you're using a nice ruler. I'm going to be trying to draw a straight line on this, so you're going to be a little bit more accurate and have it on paper and use a ruler to really make sure you're getting a straight line across. But let's take a look at this first example, a child who is 90 centimeters tall and weighs 50 pounds. So 90 centimeters, 50 pounds. So let's go back to our nomogram. Just going to erase this so it doesn't get in the way of us looking at the other measurements. So this time we're going to ignore that center bit, and you'll see on this side we have the height. So again, make sure you know which side of that line you're looking at for centimeters and inches. And over here, we have the weight, again, pounds and kilograms on each side. And what you're going to do is line up your ruler between each one, draw a line of cross, and where it lands on this line is the surface area. Okay, so let's try that out. So again, we are looking for 90 centimeters, 50 pounds. I'm just going to write that on the side here so I don't forget. 90 centimeters, 50 pounds. So let's go into where 90 centimeters is. Centimeters is on this side, so I'm going to go down and I'm looking at my 90 here. And on my weight, I'm looking at the pounds on this side and I'm going down to where 50 is. So I am going to try and draw a line. Again, you would use a ruler, making sure you're looking at where that crosses this line, not at the number, not at this dash, but where it touches that specific line. Okay, so let me draw a line here. Okay, so I've tried to be as accurate as I can on a tablet, but again, you're going to try and be a lot more accurate with your ruler. So I have it crossing the 50 here, again, where it meets, these two meet, and then here where these two meet, and I'm looking at this here, and I'm going to say this surface area is 0.8 meters squared. Okay, so now let's look at a patient who is 30 inches tall and 20 pounds. So I'm going to write that down over here. 30 inches, 20 pounds. Okay, so inches is on this side, pounds is on this side. I want 30 inches, which is right here, and 20 pounds is right here. So again, let's try and be, try and be as accurate as I possibly can between these two. Okay, I'm a little bit low there, but let's take a look. Again, we want to really double check these lines between the 0.4 and 0.5 to see what those dashes mean in between here, because it's different. You'll see the scale is different as you go up and down the line. So I'm counting, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dashes, which is telling me each of them is 0.01. So this will be 0.41, 0.42, and so on. So I'm going to count up to the line. Again, I'm a little bit low, but I think that line is where I'll take it. So 0.41, 2, 3, 4, 5. So I'm going to say that is 0.45 square meters. Okay, so that is how you use the West nomogram. So let's look at how we apply this to calculating dosages. So a child is 100 centimeters tall and weighs 10 kilograms. If the recommended dosage of a certain medication is 4 to 8 milligrams per meters squared, what is the safe dosage range for the child? So very similar to our body weight questions, but instead of just giving a weight, we're given a height because the dosage range is per meter squared instead of per, kilograms per day or so on. So let's take a look at our West nomogram and see if we can find where 100 centimeters and 10 kilograms is. So our first step is to find the body surface area. So 100 centimeters, 10 kilograms. Let's look at our chart. And 100 centimeters is going to be right there, and 10 kilograms is right here. So I'm on the right-hand side of that line. So let's try and be as accurate as we can. And then I'm going to zoom into my body surface area. And again, I'm looking at how many lines are in between here. 2, 3, 4, 5, 6, 7, 8, 10. So I'm thinking they're 0.1 each. And it's kind of right in between. And I'm pretty accurate on my lines there. So I am going to say 0.525. It's almost like right directly in between those two lines. So I'm going to do 0.525. And again, you might have found 0.52 or 0.53. That's why the West Nomogram isn't hugely accurate, but it's a good kind of estimation if you're not having to be 100% on the money accurate. The second one is going to be looking at my range. So if I have 4 milligrams in 1 meter squared, and the child is 0.525 meters squared, how many milligrams is that? Again, we're using our ratio and proportion. So I get x equals 4 times 0.525, and I get 2.1 milligrams. And then I need to do the higher part of that range. So 8 milligrams over 1 meter squared. Again, you could probably times this by 2, but I'm going to continue with our ratio and proportion just to practice. And I get x equals 8 times 0.525, and I get 4.2 milligrams. So the safe dosage range, therefore the safe dosage range is 2.1 milligrams to 4.2 milligrams. And the question doesn't give us if that's per dose or per day, so we'll just leave it at that. Okay, the next question asks, the recommended dosage of a medication is 10 to 15 milligrams per meter squared. If the physician orders a dosage of 8 milligrams for a child who is 25 inches tall and weighs 7 kilograms, should you administer it? So my first step is going to be to find the BSA. My second step is going to be to find the safe range for this child. And then my third step is going to be looking at what was ordered and is that safe? Should I administer it? Same question as, is that safe to do? So let's look at our body surface area using the West Nomogram again. For 25 inches and 7 kilograms. "25 inches, 7 kilograms." So my 25 inches is going to be right there. And then my 7 kilograms is going to be right here. Now be careful because there's a 7 on this side, but if you look at the top, that's 7 pounds. So just be really careful what side you're using of the West Nomogram because that's going to greatly change your answer. So now I'm going to be as accurate as I can. Hopefully you're more accurate using a ruler on a piece of paper. Okay, and then I'm zooming in here. And again, I'm looking at the dashes between the 3 and the 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're each worth 0.1. So it's pretty close to that top line. I'm going to say it's 1, 2, 3, 4, 5, 6, 7. I'm going to say it's 0.37 meters squared. Okay. So now I'm going to look at the safe dosage range. So 10 milligrams in 1 meter squared, or for 1 meter squared, is how many milligrams for 0.37 meters squared? So I get x equals 3.7 milligrams. And now I'm going to look at 15 milligrams per meter squared, so the higher part of that range. How many milligrams for 0.37 meters squared? And I get x equals 15 times 0.37, 5.55 milligrams. Okay, so there is my safe dosage range. So now I'm going to look at what was ordered. The physician ordered 8 milligrams. So is that 8 milligrams between those two ranges? No, it is not. So therefore, it is not safe. It is too high. So it's too high for this child. All right, so if we need to be more accurate than what the nomogram can do for us, we're going to use the formula. Now, there's two different formulas based on whether you're using the metric system or the imperial system. So if you're looking at the metric system, using kilograms and centimeters, you're going to times their height and weight together, divide by 3,600, and then take the square root of that number. And if you're using pounds and inches, it's the same idea, but you're dividing by 3,131. So you're just dividing by a different amount. So if you are given both of the measurements in either metric or imperial, you're great, you can just plug them into the formula. If you're given, let's say kilograms and inches, then you'll need to convert into one of either metric or imperial, but they both have to be in the same system in order to use the formula. Okay, so let's look at this first example, a child that is 32 inches tall and 27 pounds. What is the body surface area? In this one, they gave us inches and pounds, so we're using the imperial system, and they're both in the imperial system, so we can jump right into the formula. So body surface area is the square root of 27 times 32 over 3131. Now make sure when you're putting this in the calculator, you're using the order of operations and doing it in the right order to get the answers. So on your calculator, you might be able to do it all in one go if you're good at using brackets on your calculator. Otherwise, you're going to do 27 times 32 equals, divided by 3131 equals, and then square root your answer. And you get 0.5253 and so on. If I round to 2 decimal places, I get 0.53 meters squared. Let's look at our next question. It says 15 milligrams of medication is ordered for a child who is 50 centimeters tall and weighs 27 kilograms. The recommended dosage is 20 milligrams per meter squared. Is this safe? So let's give ourselves a little bit more space here. Okay. Our first step is going to be to find the body surface area. Similar to how we did the West Nomogram ones, we're just using the formula here. Then we're going to find the safe range. And then we're going to look at what was ordered and see if that is safe. So in this one, they gave us centimeters and kilograms, so I can use the metric formula. So body surface area equals the square root of 27 times 50 over 3600. And I get 0.61237 and so on meters squared. Now we don't want to round this number. At the very least you want to keep, 5 or 6 decimal places or so on as you go through. So the safe range is, in this case, it just gives us that 20 milligrams, but I can go up or down by 10% is our general rule if they don't give us a range. Okay, so let's see, for this child, I have 20 milligrams per 1 meter squared. How many milligrams for 0.6123 and so on? Remember, we don't round, so I get x equals 12.24744 and so on milligrams. Okay. So in this case, it doesn't give us tablets, capsules, or milliliters or anything like that. So I'm going to keep, let's say, 3 or 4 decimals here as I do my 10% because that should give me enough indication for the 15 milligrams to know whether it's in that range. So that means that I can go up or down. So the safe range is 12.2474 plus or minus 1.22474. So I divide by 10 to get my up or down number, which means I can go down by 1.22474 and up. Okay, and again, we don't need to worry about keeping too many because we're looking at 15 milligrams and comparing it to that number, and we can see that 15 milligrams is too high. That's what was ordered. So it is not safe. It is too high. So in terms of rounding for this question, because we're not given a particular syringe that we're using if it was a liquid or a particular number of tablets or capsules, there's not a given amount that we have to round to. And because they're not asking us how much medication to give them, and let's say giving us a certain number of tablet or something like that, a strength of a tablet, they're just asking if it's safe. So in that case, we want to try and not round as much as possible, but in the end, I'm just going to keep 3 or 4 decimals because that will be plenty in order to compare our 15 milligrams. Okay. So the final answer is it is not safe, it is too high. Okay, the recommended dosage for a medication is 5 to 10 milligrams per meter squared. A doctor orders 4 milligrams for a child that is 55 inches tall and weighs 100 pounds. Is this safe? So we're going to follow that same steps that we did before. We first have to see what the body surface area is because our recommended dosage is given per meter squared. So we're given inches and pounds. Again, that's our imperial formula. So body surface area equals the square root of 55 times 100 over 3131, and I get 1.3253 so on meters squared. My next step is to look at the safe range. Now in this one, they give me a range, so my 10% doesn't apply. I look at the range they gave. So I have 5 milligrams on the low end per meter squared, what is the milligrams for 1.325 and so on meters squared? Get x equals 6.6268 so on milligrams. And if I look at the higher end of that range, which is 10 milligrams per meter squared, I get 13.253, so on and so on, milligrams. So the doctor has ordered 4 milligrams. So looking at our safe range, that is not safe because it's too low. Therefore, it is not safe. It is too low. And our last one here for this type, a doctor orders 7 milligrams of medication for a patient that is 150 centimeters tall and weighs 55 kilograms. The medication has a recommended dose of 5 milligrams per meter squared. Is this safe? So we're looking at the BSA. These ones are my metric ones. So I'm doing 150 times 55 over 3600. I get 1.5138 meters squared. Then I'm looking at the safe range, which in this case, they only gave us one number, so we can do our up and down by 10%. And I get 5 milligrams per 1 meter squared. So how many milligrams for 1.5138? So on meters squared. And I get x equals 7.569 and so on milligrams. So I can go up or down by 10%. So that means I can do, if we say 7.569, we round to the 3, milligrams plus or minus 0.7569. So that means I can do 6.8121 milligrams up to 8.3259 milligrams. So now I'm going to look at what was ordered. And what was ordered was 7 milligrams. Looking at my range, that is within range, so therefore it is safe. So therefore it is within the recommended range so it is safe. Okay. The only other thing you might come across with these ones is being given a height and weight that are in different systems, and you'd have to convert them before doing the formula. Okay, the last thing I want to look at here is calculating child dosages when you're given an adult recommended dosage. So there is a formula for this. So the adult dosage might just be a certain amount of milligrams. It's not per weight, it's not per body surface area or whatever, but it's an adult dosage. And so we can use the child's body surface area to figure out what the child's safe range would be when given an adult dose. And the formula for that is the body surface area of the child divided by 1.7 times the adult dosage. And that 1.7 comes from the average adult body surface area. Okay, and that will give us what that child's should be. So for example, the normal adult dosage range of a medication is 5 to 15 milligrams. What is the safe dosage range for a child with a body surface area of 1.5 meters squared? So I'm going to do the low end of the range and the high end of the range. So we'll have to do the formula twice. But we can do 1.5 meters squared divided by 1.7 meters squared times 5 milligrams to figure out the low end of that range. And I get 4.417, so on and so on, milligrams. And looking logically at this number, it makes sense that it would be close to 5 because the body surface area of this child is close to the average body surface area of an adult. So the closer that the body surface area is to 1.7, the closer their dosage will be to the adult's dosage. Okay, and then I can do the high end of that range. I'm going to start off the same, but then I'm timesing it by 15 milligrams. And I get 13.2352 milligrams. So if we round them, let's say to 2 decimal places, I get 4.42 milligrams up to 13.24 milligrams, and that would be the safe dosage range for that child. Okay, 5 milligrams of medication is ordered for a child with a body surface area of 0.8 meters squared. If the average adult dosage is 20 milligrams, is the pediatric dosage correct? So the first thing we're going to do is figure out the child's dosage based on the formula. So we have 0.8 meters squared is the child in this case, divided by 1.7, and we're timesing by 20, which is the average adult dosage. And we get 9.41, 17, so on, milligrams. And because this isn't a range, we can look at the 10%. So that means we can do 9.4117 and so on, plus or 0.941 and so on. So that means we can do as low as 8.47, if I round to 2 decimal places, up to 10.35 milligrams. So is this pediatric dosage correct? We need to look at what was ordered, and that is 5 milligrams. So is it correct? No, it is too high. Therefore, it is not correct. It is too high. Okay, and the last one here, 80 milligrams BID, which means twice a day, of medication is ordered for a child with body surface area of 1.22 meters squared. The average adult dosage is 225 to 250 milligrams per day. Is the dosage correct? So the first thing I'm going to do is figure out what the safe dosage range is for this child. Now they've given us a range, so our 10% doesn't come into effect here. So we're going to do 1.22 divided by 1.7 times 225. So we'll do the lower end of that range first. And I get 161.7 0.47 milligrams per day. And I like to write that per day there just so that I'm not confusing that with how much per dose. Then I'm going to repeat that for the upper range. And I get 179.41 milligrams per day. So that is my safe dosage range. Now I'm going to look at what was ordered. Now ordered in this case was 80 milligrams twice a day, which is 160 milligrams per day. So is that the correct dosage? No, it is a little bit too low. Okay, so this is how you calculate the child dose when given an adult dose. We also talked about how to calculate dosages when using the body surface area formula, and then we looked at how to do it if you're using the West nomogram.